Hello everyone, this is my CIS 9467 final project for Professor Adrian. In this video, I'll be showing how do we use solver and other Excel techniques to find out the maximum profit and break-even point for a noodle store. So let's begin. In this example, the store sells 4 different types of noodles. The beef, pork, seafood, and vegetable all sell at a price of $9. Imagine we have this amount of inventory left that are colored in green, and the one colored in purple are the recipes for making the noodle. We want to find out what is the maximum revenue the store could get by use as much as the inventory left. We'll do that by creating a solver equation by set the objective to be maximize the total revenue, so it's this cell, by changing the quantity number over here and also to include some constraints. The number one constraint we want to include is to have the inventory left be greater or equal to 0, so we don't want any negative numbers. And number two constraint is to have set the quantity as an integer, not any number with decimal points. So if we click data and go to solver, by inputting the parameters I have over here and click solve, we'll then get this answer report. So based on the answer report, the maximum profit the store could get is $7,704, and ideally they should sell this amount of noodles. And as you can see from the answer report, the original number the Excel calculated is numbers with decimal points for the seafood and vegetable noodle. So our final answer was rounded down to whole integers because we have one of the constraints we have is to set the quantity equal to integer. Next, let's look at the income statement that I set up for this company. So if the company is operating at 365 days and the units sold per day is 380 when they sell at price of 9, then this is the total revenue the company should be expecting getting. The company also have some variable costs that are cost per unit and wages per day and also fixed costs over here. If we added all the expenses together, then it should be this number. And if we calculate it, the final net income the company should get is $23,069. Underneath it is a profit margin equation. By dividing the net income by the total revenue, it's telling you how profitable the company is making. I also have a demand curve. We expect the number of demands increase when we sell at a lower price and number of demands to decrease when the price increases. Then I did 2 data tables by using the data what if analysis data table. Table number 1 shows the revenue, the cost, and income for the company when they sell at different price levels. These 3 numbers are directly equal to the ones shown in the income statement. And if we click it and then right click it, go to formatting cells, go to custom and click these 2 symbols, the number could be disappeared. This conditional formatting over here tells the strength of the numbers. When the net income is a negative number, it is in color red, and when it's green, it's telling that the net income is positive. Data table 2 is a 2 variable table. Variable number 1 is the price and variable number 2 is the days of operation. So here's the final net income the company should be getting when they operate at different levels. This is also a conditional formatting. Go to home and then conditional formatting, the manage rules. As you can see that I set up any results if the final result is less than 0, it should be colored in red. If it's greater than 35,000, it should be green, and if the number is in between this, it should be in yellow. This is a very helpful tool as it provides us a more clear view on how the company is operating. This is a sparkling line based on the 3 results I have over here. I also formatted so that any negative numbers is colored in red and any positive numbers will be colored in green. Here are 2 buttons. By clicking developer and then go to insert, form controls, here's the spin buttons. If we right click it, you can see how I formatted. So the minimum value should be 0 and the maximum value should be 365. It represents the days of operation, and the range I set is 5 days as the incremental change. And the cell link is linked to E7, which is the days operation. If we click the button to be 350, which means the company operates 350 days per year and sells at unit price of 9, then the total income, the revenue, the net income number changes. These are, I think the buttons are a very helpful tool as it tells the company owners what is the net income or the number they should be expecting when they sell at different price level or operate in different days. Besides the maximum profit, it is very important for business owners to know what is the break-even point. So here is the break-even point worksheet. Same thing, we'll find out the answer by setting up a solver equation to set the net income, this cell equal to 0, and by changing the variables over here, the unit price, and also to put some constraints. If we go to data and then solver, by inputting all the parameters shown over here and click solve, we'll get this answer report over here. And it's telling us that the days of operation is 365 and the final value should be 8.71, which means if they sell at $8.71, the total net income should be 0. We could also change it, click solver, by adding another constraint. Let's say if the days of operation is equal to 325, which they only operate 325 days, click OK, and then click solve. Then it will tell you that the unit price should be $8.84 in order to reach net income to be 0. The break-even point analysis is also important, so the business owners will know that what is the least price they should sell in order to not have a loss. Overall, I think Solver is a very powerful tool, and it actually helps us to see or help the business owners to view what they are expecting. So this is all my final. Thank you for listening.